Afternoon, everyone. Welcome to another episode of Dispatches from Energy Transition. It's hard to believe that it's been 2 years already, but Lucas and I are getting ready to wrap up the year with our last episode of 2025, winning energy storage projects through smart design. This is a big topic for our audience, but it's predominantly focused on C&I and the mid-market segment, and we're happy to have you here today. I'm Robert Cross. I'm the principal of Outfit. We are a design studio that helps our clients enable the energy transition through technical marketing, visual storytelling, and bold ideas. As always, I'm here today with Lucas, who I've actually known for almost a decade, I think. So, Lucas, how are you? Ready for this topic today?
Time flies. Yeah, excited for this topic. Excited to end the year on a high note and just excited for this group. I think it's a big topic for us and one that we've been thinking a lot about throughout 2025 and we're really focused on for 2026. But we have a lot to cover today, a few case studies that we want to try to get to as well. So I'm going to keep us moving and focus really on our guests. And first, I want to introduce Jacob Betcher, our CEO here at Mayfield Renewables. Jacob, it's great to see you on a Dispatches. Do you want to introduce yourself and tell the audience a little bit more about Mayfield?
Sure. Yeah, thanks, Lucas and Robert. I'm excited for this as well. Um, I'm CEO at Mayfield Renewables. If you don't know Mayfield well, we primarily focus on electrical engineering. It's our bread and butter. It's what we do every day. And we focus on this mid-market, as Robert was discussing, the CNI and community scale projects. In doing this, yearly, we do hundreds and hundreds of these projects, and we see a lot of issues. And as we've seen these issues, we've been slowly building out products and helping our clients to come to the table, to come to our engineering table more ready. One of the key things we've been doing a lot of is this feasibility analysis. We'll discuss a lot about that today and what it means at a very high level and ways to think about it. The other thing that we do is give back to this community in our educational pieces. So doing things like this, where we're really trying to engage with our community a lot with education, trying to help bring all of our learnings and experience back to this community.
Great. Thank you, Jacob. I also want to kick out to Casey Miller from Elexity, CEO at Elexity. Casey, thank you so much for joining us. You want to tell the audience a little bit about your background and about what Elexity does?
Yeah, thanks, Lucas and Jacob and Robert. Really excited to be here today. I've known Ryan Mayfield and the team for a long time, and it's fun to participate in an event like this that's, as Jacob said, educationally oriented. And I'll share a little of my background, a little bit about Elexity, if you don't know about Elexity. So first, I'm an engineer by training and have been in renewables since about 2009 with firms like PV Powered, Chint Power Systems, and now Elexity. I'm based in Bend, Oregon, but most of our team at Elexity is in Portland. What do we do at Elexity? So we're an energy management system. We're a platform that optimizes and controls batteries and loads in commercial and industrial buildings. We're passionate about helping our developer customers win more projects with a better solution, with better economics and a complete platform for their customers. Really excited to share what we have for you today. Hopefully it'll be educational.
Thank you, Casey. Thank you, Jacob. Jacob, I feel since you've been on board that you and I have been spending the better part off and on of the past 2 years in regard to feasibility studies, and the commercialization of projects. Why don't you walk through from Mayfield's perspective, and as we're heading into the new year, what we're looking at here for the CNI market segment?
Absolutely. Yeah, just by happenstance, Robert and Casey and I happen to be all in the same town and enjoy the same coffee shop. So we do get to spend some good time together. What we're talking about here is what it takes to set up a project. If we're talking about CNI scale development, this is where I mentally start. And this has, as we have here, three pillars of engagement that needs to happen to get the project off the ground and moving in a good direction. First one is establishing the project goals. This really comes down to stakeholders. We'll discuss that in a couple of minutes. Second one is about the site. This is the actual physical place, what it is, what it's not, and all of the details that are going to impact construction, O&M, and every other piece of this project. The third one is the actual work of the feasibility. It takes the information from the first two pillars, and then you build it into computer models so that you can really analyze the relative value of the project. How much is it addressing the project goals? How much is it paying back? How much is it, if this is resilience, that type of stuff. So yeah, these are the three goals or the three pillars. We'll be talking about this in the next three sections.
Jacob, we talk to project developers all the time from a Mayfield lens. How important do you feel feasibility is? And
Um,
what do you think developers need to look out for in the new year?
I think feasibility is very important. Probably the most difficult thing about feasibility is it's not a one size fits all solution. There are different project types, different goals that really require different approaches to feasibility. But understanding those differences, understanding what the real needs are is extremely important. There's too many times we get halfway through engineering and realize that the project has been what we consider underdeveloped, meaning that we're getting into engineering, we're doing engineering work, we're spending a lot of time putting together the right package, but the goals have not been appropriately identified. The key stakeholders have not been brought into the room at the right times. And somebody asks, how long is my battery going to keep the lights on? And when our engineers hear that, it's immediate red flag saying, okay, this was not done early enough. And we've even had it where someone's asked that question and it's not a microgrid. It doesn't have the ability to keep the lights on. So these are the kinds of things that this answers up front. Make sure that we're moving in the right direction to start with so that engineering doesn't end up taking much longer and costing much more before that project can get off the ground.
What type of projects goals are we talking about here? I mean, there's economic, technical. Let's walk through these at a high level.
So these goals can be wide ranging. These can be economic. It could be that you're trying to reduce energy costs or protect yourself against future energy cost raises. This could be resilience goals where you want to make sure your manufacturing line stays on if the power blips or goes out for 2 hours, or if you're looking at potential rolling blackouts, what that could mean. We also do a lot of work that is shelter based. So, you have a major storm or event. How do you create a community shelter using renewables in case the power goes out, in case there's heavy weather, very cold, very hot type of a thing. All of these can be those goals. The one thing I will add to that is this stakeholder engagement is so important. There are some projects that take a few stakeholders. Owner operators take less stakeholders typically. However, there's usually a community side to it where if you don't engage the broader community, you can get pushback. We've seen this with some of our clients as well, where they will start into a project and not go through the community engagement and bring to the community the benefits of the project. And in the end, the community pushes back because of their perceptions of things that may or may not be real. It's hard to fight against something that's already going down a negative road. So this community engagement or the stakeholder engagement early on, making sure that everyone understands the value, understands also the limitations that can happen in these projects. Many of our stakeholder meetings have more to do with putting reality into the stakeholders. Um, these systems cannot both do resilience and energy arbitrage with the same power. For instance, you have to separate those two when you're doing modeling. Casey, do you have anything you want to add to that or examples?
Yeah, you know, developers, when you get that verbal yes to move forward on a project, you want to move fast and you want to get to you want to get after building, right? It's hard to take a moment up front and take the time up front to pause and make sure you've got alignment with all the stakeholders. I mean, it's kind of an unnatural step, but it's a necessary step to get it right. Um, we've seen examples where an economic benefit of, say, a battery system has been shared with the customer, um, but it wasn't tested against the reality of what the utility rules for that site allowed, things like whether it could export or not export. And then you get to a point where you've got misaligned expectations with the customer, and that can be a project failure. So, um, doing this work up front, engaging the stakeholders, doing the feasibility work, I think it's just really critical to a successful project. Um, the other comment I would make is that batteries are a Swiss Army knife kind of tool. They can be used in so many different ways. We'll show a couple examples of the value that you can get from a battery. Um, we often use the word stacking value to generate, a benefit for a customer to do a project. And that just takes good thinking up front. It takes an understanding of the building and the use case, um, and some good planning. So this is just a critical step to get that right.
Casey and Jacob, I keep hearing you both say it requires good thinking up front. How often is that happening on projects? I'm just kind of curious. Is it 25% of the time, 50% of the time? Just from your respective lenses and for our audience, how big of a problem is this?
Um, I guess I'll start with I think most people are making efforts at this. Um, the level of detail that people are going into varies quite a lot. And that sometimes is enough. Sometimes it could or should have been more. It would, in the long run, reduce either the cost of the project because of timing overruns, things like that, or reduce the risk. A big piece of this feasibility work is really reducing the risk along the way. And each piece that you do reduces some amount of risk. So understanding where those risks are really should set the level of what feasibility you need to be doing for each stage.
We're
Casey,
going
do
to take
you
a
want
look
to win
at.
there? I'm sorry, Lucas.
No,
I
no, no,
just
go for it. Go for it.
yeah. I was curious about Casey's perspective as well, because you talk to project developers all the time with
Yeah.
Elexity. How big of an issue is wrapping your arms around the project the right way as we head into the new year with your
Mhm.
clients?
Yeah. It's a tough question, but I'd answer it this way. In terms of relatively big impacts to the project down the road, like big misses, um, unfortunately, I'd say probably at least to the quarter of the projects that we've seen or been involved with, um, we've seen that there's economic opportunity or costs that were missed or things that were kind of left on the table just because projects moved a little too fast through this feasibility phase. Um, and that varies depending on project complexity and the use cases, but um, Yeah, I think this is just this an area where, it's uh, the applications and use of batteries is relatively complex, and it's easy to miss some opportunity without good planning. We see it pretty often.
Yeah, and we've got a handful of examples to look at here coming up next. But last thing I want to mention on goal setting and something that we try to really embed in our feasibilities at Mayfield is not only your goals today, but your goals over the next few years. Maybe you're going to add EV charging. Maybe the way you use your industrial facility is going to change. You're going to start manufacturing different products than you were previously. Your load shape is going to change over time. If those are things you anticipate in the next few years and we're designing your microgrid today, that can be a part of this conversation in pillar number one of goal setting is not only what is an accurate picture of the site today, but hey, let's talk about your goals for the next few years and maybe we can address those proactively with the system so you don't have to make changes later on. You can do your whole investment today and it'll make sense today and in the future. But I do want to keep us moving. I know we've got a couple examples here. Um, and turning it to you, Casey, to start us out, just kind of what are we looking at here with this high school load profile? How do you interpret this when you see a graph like this?
Yeah. All right. Now we're going to nerd out on load profiles and data, which is what we love to do at Elexity. Actually, before I jump into this, let me frame some context. The good old days of solar, when we could just install solar and maximize a rooftop or a carport and count on spinning the meter backwards and those customers getting paid for it, in many ways allowed us to not have to go and look at load profiles and energy use in great detail, right? Because we could go drive economic benefit through solar that way. In the new world of NEM 3 in California, um, and in battery use cases in general, you really have to match a battery's or an energy storage's storage system's design and capacity to the use case itself. And the use case is, well, what does energy use look like in that building or facility? We're going to show you three examples. We'll go relatively quick, but it gives you a sense of the variety that we encounter with different building types. The first shown is a high school. This is in California. This customer's goal is to maximize the return on investment of that battery to deliver bill savings. The load profile, a little bit about the data that you're seeing. This is one day. This is a peak day in the summer. This is actual building data. The dark gray shadow looking profile, that's the baseline energy use. This is what the building is consuming on a 15-minute level or increment in this one day. On the left is, or the axis on the left is demand, so kilowatt. And the axis on the right is temperature, and we'll talk about that. This is a pretty typical example of a California high school. Base load during the night, around 50 kilowatt, pretty steady. Big peak of energy use during the middle of the day that corresponds to with the temperature rise. Why is that? It's HVAC use. This is HVAC driven in the summertime, cooling driven energy use. Solar is the blue line. So this is after solar. What does that profile look like? Well, solar does an awesome job of attacking the energy during the middle of the day. But because this is a summer day, as the sun sets, energy use is still quite high, and you're left with that kind of hill on the right-hand side, a peak driven by HVAC use. This is a pretty typical example of an HVAC-driven load profile in a location like California, where there's quite a bit of air conditioning use.
Casey, we have a great audience question here from Howard Cleaver. For sites with poor interval data or no interval data, what's the fastest, most reliable way to size the system with acceptable risk? And I guess
Yeah,
that's what a lot of this has to come down to, right? Like speed, efficiency, but risk management.
yeah, great question, Howard. Thanks. Yeah, it's a difficult one, right? In an ideal world, we get 15, a year of 15-minute data from a site to look at the detail of what a battery can do. Without that, there are a couple methods. There are generic load profiles for building types. NREL and others have published data profiles like that. We've looked at over 1,000 buildings at Elexity and have a good understanding of typical use cases. Um, and we can provide reasonable estimates with that data, but the developer's going to have to accept some risk on what the economic benefit is without good data. And that's just a conversation with the developer.
Yeah, and I'll just add, at least on Mayfield's side with our feasibilities, that's a huge part of the early process is data gathering, RFI submittals. And oftentimes we do have to make assumptions, and we're just really careful to note those in our final report. So the outcomes of our analysis are clear, but so are, hey, we maybe didn't have interval data for this project, so we had to scale a representative load profile instead. So maybe take the results with a tiny grain of salt. Like we have a confidence interval for our estimations, but it will never be 100% confidence. So just noting all of your assumptions, all of the edits you've had to make to your data can also go a long way when you're in this preliminary analysis stage.
Yeah.
But Jacob, I don't know if you have anything else to add on the Mayfield side of kind of how we generally approach that early stage of a feasibility and like getting to know the site in general.
Yeah, there's more to it than just the energy. The energy is one of the most important pieces to that model. Um, there are we have also done, where you go install a meter and you actually collect data for a shorter period of time because you typically don't want to spend a year doing this. You collect a short amount of time data, maybe a month or something, and then you scale some of these other energy models around the year to make an approximation. So there are other ways of doing this. A lot of it comes back to this risk mitigation question. How important is the risk to you as a developer, as a site owner, as an asset owner in the long run? Um, with projects that are very, very tied to the revenue return, this is something that is much more important in that you can start failing on this project if you don't get it right. In those situations, you really need to reduce the risk better somehow. You need to find a way. Other situations are more along the lines of resiliency, right? Where you're looking at, okay, we need to have 2 days of backup for your selected loads. In that case, if that turns out to be plus or minus a day, you need to scale that risk appropriately, and then you can be in a much better place. So it comes down to really understanding the goals and the risks associated, and looking at these with that lens and making sure that you have the data you need to address the risks. And
Me too.
Lucas, to your other point, I think beyond the electrical loads, there's many other things on the site that you also need to be looking at. The electrical loads are one of the biggest pieces, but whether you have concrete and are going to have to trench through it, um, if your structure is capable of holding solar, there's many, many other site pieces that go into this second pillar. Um, we end up digging into this electrical load piece a lot because this is the core of a lot of the actual model piece of it. Go ahead, Robert, you were talking.
Oh, it's okay. Um, Great feedback on one example. Casey, you're familiar with this example. I know that Electricity is heading to the National Auto Dealers Association conference coming up soon. You work with a lot of car dealerships. Let's walk through this here.
Yeah, here's another example. It looks similar to the high school. This is a car dealership in Texas. The data is a little smoother. Why is that? Well, we actually have 30-minute interval data versus 15-minute data from this utility. So you might notice that solar is doing a similar thing to the baseline data, attacking a lot of that during the middle of the day, leaving kind of these horns on the front end and the back end of the day. And that's the net load after solar that we're really looking at to decide how to attack that with the battery. But this customer's use case was more about, hey, give me some bill savings to help pay for resilience. And I want a couple hours at least to back up, ideally four, make that the most affordable you can. So reduce my bill with the battery when you can do that, and give me resiliency when I need it. Very different use case than the high school before. A little bit similar load profile. This is actually a fall day, so you see a little bit of heating in the morning, that morning horn, and some cooling in the afternoon. Robert, you talked about NADA and dealerships. This is a big segment target for us at Elexity. This is a customer type that needs help to both manage their building and control their energy costs. And kind of back to the feasibility question and some of the things Jacob was talking about earlier, um, their buildings are changing. They're adding things like EV chargers to their electric load over the next few years. And so this is a segment that we focus on, serving this segment quite a bit. They need platforms like what Elexity can offer. I think we have one more profile to look at that's quite a bit different than this, and that's a manufacturing facility. And hopefully, what jumps off the page a little bit to you is their energy use looks very similar 24/7. Why is that? They're running three shifts, and they're really never having a period of time during that 24-hour period where they're just at base loads and maybe just keeping the lights on. You see some peaks throughout those shifts when things like motor loads turn on, but this is a very different picture than what you saw with the high school and with the car dealership. Again, solar does a great job of attacking the middle of the day, but you're left with quite a bit of time to manage those loads that are over a megawatt at peak.
I have a general question. I'll kind of open up the floor, including you, Lucas. The CNI market segment has lagged residential and utility scale in part due to complexity, right? There's a lot of business types, building types. Where do you see the greatest low hanging fruit in the segment? So if I'm like what segment type or building type do you think we should really be paying attention to heading into the new year? Or is it all of them?
I'll take that to start with. First, I think all of them to some extent. We really like to see this expanding, but I think this is market dependent. Certain markets, certain utilities value batteries different than others. Certain markets really value resilience or shelter, things like that. So each market really has its areas that are showing the most value in the market today. And each region is very different.
You see from your perspective, is it refrigeration? Is it CNI? I mean, you've been in the industry a really long time and have seen on the hardware side, the software side, what's your perspective heading into the
Yeah. Well, it's a big question, Robert. I would say this from a battery perspective, really customers in the CNI space are motivated by economics, either the benefit of resiliency to keep business operations running or attacking a really expensive energy bill. And if you're in a location, if you have like a 50,000 square foot building or larger in San Diego, you're going to have a 2 to 3 year payback on a 125 kilowatt 2 hour battery just to attack those $90 a kilowatt peak demand charges and high energy prices. If you're in Southern California, it might be a 3 or 4 year payback period to either do arbitrage or attack demand charges. We see programs in the Northeast, like with Eversource and National Grid, or now PJM, where participating in grid services can generate almost equivalent payback periods as you do in Southern California. Um, so, I mean, there's a lot of variability around the country. And one of the things we look at when we model, of course, are the electricity rates and where they're headed and how they're increasing. Um, but there's some locations in this country where it is a no-brainer economically to install a battery, whether it's for in a microgrid case or an on-grid situation.
Well, let's take a look at, I want the audience to kind of hold these three sites in mind for the rest of the slides here. We're really going to deep dive into each of these and a head-to-head comparison of, is a microgrid the right solution for these sites? What is the impact that a BESS could have financially or otherwise? We're going to kind of build this slide up a little bit piece by piece to do that head-to-head comparison and then end with a few case studies. Jacob, maybe let's start with you. So we are in what we're calling the third pillar at this point. So we're in modeling, executing on the project plan. And talk a little bit more broadly, I guess, about what stage we're at here in the process and really what goes into this third pillar.
So this is where everything starts to come together. This is where you're actually doing the analysis of the different pieces. You're building a computer model of the site. You're looking at what economic benefits there are, what resiliency you can achieve. As you change things, this is where you can also test things. You want to do larger, smaller BESS. You want to bring on this dynamic load control that we'll talk about in a minute. You want to bring these things in and start really analyzing what the site or what this project is going to look like, and how that's going to best achieve your goals. This includes things like the actual model, which there's a number of providers out there that have software for this, but you have to have the understanding of these modeling software packages to be able to select the ones that make the most sense for the project type, the efficiency, everything else. This is also where you're really looking at, okay, what feasibility is needed to reduce risk for this specific project rather than being an all-inclusive option. So as we bring this together on what's on the screen here, we're looking at this high school now, and the goal is to maximize ROI. And initially it's, okay, what happens with solar and storage, and how is that ROI looking? And then this dynamic load control, which I think Casey's going to jump into what that means next, is another additional piece to this specific one that's very interesting.
Yeah, do you want to take that, Casey? Kind of walk us through so folks can see here in the legend at the bottom. We'll have three more examples on screen, but we're comparing with and without load control here. So what do we mean by dynamic load control?
Yeah. Dynamic load control is shifting major electrical loads in a building real time with an intelligent control system that's aware of grid prices, energy use, and the load profile real time that's happening in the building, and flexing those loads to either reduce the bill or extend the life of a battery in a backup event. The two major electrical loads that we focus on at Elexity are HVAC and EV charging. And in the commercial segment, HVAC still really dominates most of the load profile in most commercial buildings. And you saw that with a couple of the baseline pictures that we shared before. And so if you can intelligently shift HVAC loads in concert with the battery and real-time prices, you can drive a more economic benefit for the customer. And we model that with our platform to determine what the economic benefits could be for load control. The load control is not always a fit, and we'll show you that as well. But at a high level, that's what load control is.
Yeah, and we got a great question from Andre in the audience asking, is there a solution for CNI sized batteries that would work similar to Tesla's Storm Watch function? So software that can monitor weather and climate and switch battery capacity between peak shaving to resiliency or other functions. So I'd open this up to either of you, and maybe it's not the battery, it's the EMS, but how would you guys approach that question?
Yeah, I love that question. Yeah, actually, a little self-promoting about Elexity. We won a DOE grant a few years back to develop a similar technology. We monitor the risk of grid outage and dynamically allocate the battery capacity for a potential resiliency event. And what does that mean? In a microgrid design, kind of historically, often the design would make an assumption to allocate a percentage of the battery for backup at all times, and the rest of the battery for on-grid savings. But if you can dynamically allocate that based on the risk of outage, which we do at Elexity, then you can get better on-bill savings during low weather risk or low grid outage risk scenarios and offer more resiliency during high risk scenarios. There's more data like that that's available, more forecasting data that's available. So you need an EMS platform that takes all those inputs and is intelligently allocating the battery, for its purpose. So I love the question. And it's certainly something we do with our platform, but that intelligence is going to live at the EMS level, not at the battery itself.
I'll give a little bit more of a product agnostic view of that. I fully agree with Casey that yes, this typically lands at the EMS level, and there's quite a number of companies out there that are doing this. I'm sure each one is doing it in its own way and has its own relative benefits. I love working with Elexity and am always a proponent of this because this is something that a lot of the industry doesn't think about that much. I think that as microgrids are coming together, there's a lot of the industry that is leaving, as Casey said earlier, some money on the table when they're not actually analyzing this and looking for this EMS layer solution, or if even if a battery integrator has this type of solution, they're not critically analyzing the difference in those and how that can add benefit to your battery while reducing risk. So it comes back to that risk thing. If you're only looking at the time of year and you're adjusting how much battery you're keeping for resilience, that's the first level. The second level is what Casey's talking about, which is that, okay, we're analyzing local weather data to predict risk. So it comes back to that risk question again.
I'll just add one more point. What we're talking a lot about here is the modeling up front. We model up front based on historical data, based on weather data, based on estimates of production, estimates of where utility rates go. But in reality, a year or 2 or 5 years down the road, once that asset's operating in the building, it needs to be dynamic. The control scheme needs to be able to adapt to changing utility prices that could change dramatically, or the availability of grid services programs. This is about kind of planning and doing the best modeling you can to anticipate the benefits for the customer, but you've got to be able to dynamically operate the battery in the future because prices change, operations change, the building changes, et cetera.
Yeah, and maybe sticking on benefits, I think looking back at the slide here, we have this slider bar with what we're calling relative benefit. This is somewhat of an arbitrary metric that we've come up with here. And as we go through each of these examples, you'll see, one could be a financial benefit, one could be a performance benefit. So we're kind of broadly bucketing these together into what's beneficial for this site, for this project, for these stakeholders. So with that in mind, maybe Casey, do you want to walk us through kind of the high school and then these second and third examples we've got here?
Yeah, so for the high school, we showed you the baseline data before, and if we have time today, we'll show you the kind of after load control benefits. But the big picture is because that building had so much HVAC use, adding load control boosted the savings or the economic benefit relative to the battery by about 50%. So imagine applying a 50% bonus to your economic equation when you're out trying to develop a battery. That's significant. And we've been demonstrating this success at this particular site. The next example is a little bit different. This was the car dealership that wanted some economic benefit from bill savings, but really needed a battery for resiliency. And they highly valued resiliency, so that the without load control, you know, marker is a little further to the right just because of the customer's perceived value of business continuity was quite high. Um, and there we applied load control, not so much to reduce the bill, although it does do that, but to try to increase the duration of the battery during an outage event. The alternative to dynamic load control would be to go shut off the breakers and turn off the loads in the building. But what we can do at Elexity, this is a dealership, you remember the baseline was still have pretty heavy HVAC. We can reduce HVAC use while still keeping the building comfortable, or at least within what is acceptable to them during an outage, and dramatically increase the duration of the battery. So they could buy a smaller battery or get more duration with a larger battery. So that was a key benefit there. And the next example, a little bit different. This is a manufacturing facility. You remember the 3 shifts baseline kind of all the time. Load control did not have a benefit there. Those manufacturing, most of that load was driven by manufacturing equipment, motor loads that really weren't flexible. Um, and so actually, we could apply load control, but it'd be an incremental cost, and so a net negative on the benefit to the customer. So just not a good use case for controlling HVAC or EV chargers. Even though that manufacturing facility had HVAC use, by far most of its load profile was dominated by inflexible manufacturing operations. So
It's
yeah, go ahead,
PT,
Robert.
yeah, you bring up a point. I mean, we talk about this quite a bit over this past year. Buildings are dynamic. Um, Working in this industry a long time, the rate of change, the acceleration of change with utilities, and the adoption of batteries, we're in a very dynamic environment, like, period. So I'm just kind of curious. Like, I feel Alexity from the software side and then Mayfield consulting engineering, you're trying to mitigate risk and align opportunity for the dynamism. I'm just, again, kind of like stepping out of specific case studies a little bit and looking at the broader picture. How does Mayfield and Alexity help your partners, help your customers with the rate of change and the dynamic nature of this industry?
Yeah, great question. Well, look, I think we share the objective of maximizing benefit and minimizing risk for our developer customers and their end customer. Um, good planning and modeling helps do that. A couple examples. Batteries can also be modular. You can plan to start with one battery size today to fit the load you have, but with good planning, you may be able to make it easy for that customer to add additional battery capacity to that site over time. That's one example of thoughtful design and engineering up front that can make that battery system more flexible over time to adapt to the building's use. Um, Another example, with our platform, it's a platform. It's not just battery optimization, but it's load control, it's EV charger management. And so customers can add, if they add an EV charger later down the road, that's something that we can manage as part of our platform. So it helps future-proof, against changes that they have in front of them. Um, Those are a couple examples. Jacob, do you want to add anything there?
I just want to add something for Jacob, and then like Lucas can kind of jump in. I mean, being in the industry a long time and working with Mayfield and following Mayfield, I think education is becoming increasingly important for the entire industry, in part because, as you guys talked about looking backwards, it was about maximizing roof space. And today and tomorrow, it's not. Like, it's a lot more complex hardware, software, policy around. But Jacob, I'll let you provide the advantage.
Yeah, as you said, the rate of change in this market is very large. It's growing very fast as well. There's a challenge with that rate of change in that there's a lot of new people coming to the market. And for our part of the market, which is that middle market, there's people coming from residential, there's people coming from the utility scale. There's some complexities here that are very unique to the market, and we do need to continually educate and grow and help people understand things. If I take it from a little bit different perspective, our clients are developers who are doing a number of projects per year. They are seeing the projects that they're doing. As engineers, we see hundreds, often 10 times plus what our clients are seeing for projects. And this gives us the unique advantage of learning things much quicker. So part of that, again, is bringing that back to the industry. One of the reasons I was really excited about this call today is talking about this dynamic load control, what Elexity brings to the table here. I'm going to make a little pitch for Elexity. This is something that a lot of the industry doesn't know about. The industry doesn't really know that it's available. It's something that can add value, and it's relatively straightforward. This is not brand new technology. It is taking technology that's been in the industry for a long time and bringing it together into this ability to control a microgrid and a facility. And this slide shows very well, just like some places, it's almost a no-brainer to bring this into this type of technology into the project. And for Mayfield, this is something that we're pretty passionate about. It's like, okay, as we're learning about all these different things, we're doing hundreds of projects. We want the industry to know about all of these different things so that we can maximize the benefit of each of these projects as they're being worked through. So really glad to be here. Really glad to have Casey on the call today and be able to show this to the industry, to those folks who have not yet seen this. And hopefully there's some light bulbs going off saying, hey, that might be useful on another project, or hey, let's get in and do a little bit deeper dive to mitigate some risk. These are the kinds of things I'm hoping to inspire in the community.
Well, I know we've got a couple case studies to look at, but we did get one great question from Howard. I want to just quickly put in there and see what you guys have for it. So, what's the biggest delta you've ever seen between original feasibility versus actual performance? So this could be improper goal setting, you name it, but just a delta, an example that you guys have seen of maybe things going wrong.
The delta between what was modeled and what was actually delivered?
Yeah.
Yeah. Good question. It can go both ways, right? We have seen cases where, look, buildings are so poorly managed today that there are a tremendous number of just energy mistakes that happen. And so we have certainly seen a number of cases where load control actually creates kind of twice the benefit we had modeled, just because, frankly, car dealerships don't have time to pay attention to tuning the knobs and operating their building all the time, and the occupants make energy mistakes all the time. The service manager leaves the service bay at 5 p.m. on Friday and sets the air conditioning to 70 degrees and it runs all weekend unnecessarily. So some of those things we can't model, but turn out to be significant upside um, after the fact. Um, we have seen the other case, and I shared an example before um, of of a customer that set sort of a savings expectation for a customer and that we modeled appropriately, but they didn't design the system to enable that through the interconnect with the local utility, meaning the interconnection agreement limited their use case of the battery, and so it under-delivered on what they had promised and what we had modeled. And again, that's the kind of error proofing that you want to do in the feasibility study. Um, in that case, boy, it's off the top of my head, but it probably under delivers by about 30% because of a technical interconnect limitation that was missed.
I'll talk about this on a little bit different direction. Casey gets to see, and he's part of that operation of the systems um, afterwards, so he gets to see a lot more detail on that. One of the things we've seen at Mayfield is that people will come to us asking about feasibility, and they have conceptions about what their products are going to do, how they will perform. And the number of times that we've gone through the feasibility efforts, starting with these three pillars, working through with the clients, and getting to the point at the end of the day where they have completely changed their expectations or changed the products that were used, the sizes of things that were used because of that feasibility analysis. And that is something we see probably more often than not, is that the feasibility study led to core changes in the design of the system before engineering happened. All of that would have ended up happening after engineering, and a large timeline delay and other risks that would have come up because it was not done early. But we do see quite a lot of change early on in that project because of the feasibility analysis.
Last thing I'll add, and then I know we've got a case study to run through here, is just don't forget these are long-term assets and operations do matter. We worked on one of our first microgrid projects back in 2019. Went really well, went through feasibility, design, construction. The facility manager left and did not hand off the documentation and responsibilities of maintaining the microgrid to the succeeding facility manager. And so when we went in and looked at the data 5 years later, the system was operating at half capacity because nobody was keeping an eye on it, doing basic maintenance and upkeep, or even paying attention to the monitoring. So going back to stakeholders, goal setting, don't forget that these are long-term assets. It's not a set it and forget it. It's a who's on site to be keeping an eye on this and making sure it's still working as intended. Well, we've got about 7 minutes here. I think, Casey, depending on how quick you are, we can definitely get through one of these. But I'll kick it to you.
Well, I'll try. And we love the questions from the audience, so keep them coming. Even if that means we just get through one of these. All right, we're going to just dive into a little bit more detail about modeling. And we're picking the second example we had, which was the car dealership that wanted both some on-bill savings and resiliency from their battery, with resiliency being the key benefit driver. So when we model at Elexity and we consider whether load control is a fit for the building or not, we look at a lot of data sources. This is one of those pieces of information that helps inform us whether load control is a fit. In fact, this is a beautiful graph. This is what you see is peak demand on the y-axis and ambient temperature. So not temperature in the building, but ambient temperature at this building. And this is every 15-minute interval plotted over a year. And what you see is a strong correlation between temperature and peak demand. At colder temperatures, kind of the smaller spike on the left-hand side, you see peak demand getting upwards of about a little over 250 kilowatts. That's from a heat pump heating in the winter. This is a site that has heat pumps for heating and for cooling, so electrical load for both. And in the summer, obviously at temperatures, getting north of 90 degrees, the peak demand of the site set by cooling. This is illustrative of a great example of a project that would be a fit for HVAC load control. Next slide. So what we do is then we model the site, and we're going to just start with a modeling of this site for resilience, assuming no load control, just baseline looking at post solar. That's the blue again, and then how would the battery support a grid outage event? And here we have a grid outage event happening in the late afternoon around 4:30 p.m. The battery charges a little bit during the day, so soaks up some of that early solar generation to charge the battery, and then that outage event happens. The next slide, Lucas. And that battery can support the site and its net load. So again, its net load is that blue graph, so post solar, and support that site for about 2.5 to 3 hours. Pretty good. But if you add load control, you get a completely different result. Load control would then reshape the load profile throughout the day, clipping some of the peaks. And you see something interesting happening between 3 and 4 on the orange line. That's Elexity's system pre-cooling the facility in anticipation of high ambient temperatures to be able to shave peaks after 4:30 p.m. and reduce the net load, thereby extending the battery life an extra hour. So Lucas, maybe just toggle back one slide and then forward again, and you can see that extension of the duration of the battery life from here to about there just by throttling back load control during that event. So a simple illustration hopefully makes the point clear about what intelligent load control software can do. And again, this happens without the customer doing anything. This happens on autopilot, right? Alexity's controlling those systems. Nobody's going into an electrical room and turning off breakers or shutting systems down. This is software-based load management that extends the life of the duration of the battery.
What do you think, Casey? 90 seconds enough to get through one more, or should we jump ahead?
Well, I'd say are there any questions from the audience?
We do have one from Howard on modeling softwares. So at which point would you bring in a power flow study, such as ETAP versus trusting software like Aurora, Helioscope, PVSys?
I think I'll let Jacob handle that one.
Yes, it's a interesting question. The real question here is when do you select different softwares? And Aurora, Helioscope, PVSys, these are different software packages that really do have value at different stages and for different times to either show what your system is going to do or reduce risk or both. The ETAP level of detail, often that's done in engineering. It can be brought in earlier if there's a specific risk to reduce. Typically, from what we've seen is that any risk associated with ETAP results can be handled during the engineering stage without significantly impacting the project. So a lot of that doesn't hit in this feasibility piece. The feasibility piece really is where you're looking at the financial risk, the little bit bigger picture risks and stuff like that. That's not to say that there wouldn't be an opportunity to bring ETAP in that stage, but you could. Yeah, I think that's pretty straightforward.
All right, we did it. We got through almost everything. We, as always, land on some key takeaways here to close us out. So kind of in line with the 3 pillars we looked at today. So first, aligning all stakeholders, keyword all, on achievable goals, keyword achievable, as early as possible, understanding your site, even going beyond electrical loads to what construction limitations there could be, maintenance, anticipated changes in the future. And then lastly, load control can unlock additional savings and performance benefits, like that car dealership example we just looked at. Want to put some contact information on screen as well. If anyone's interested, has questions for Jacob or Casey, feel free to reach out to the information here. With that, I'll open it up to the group. Any parting thoughts, Casey, Jacob, Robert?
No, I just appreciate the time of Jacob and Casey coming on today, talking about this topic. In Q4 dispatches spent a lot of focus on, as Jacob notes, a very rapidly accelerating and evolving C&I mid-market segment. We expect that to continue in the new year. Thanks to Lucas for another year of dispatches episodes. We will be back in January and have some news to share. But I think that's it for today.
Okay.
All right.
Well, thank you,
Thanks,
Casey.
everybody who attended. Thanks, Jacob. Yeah.